We're going to be talking about reliability of measures. This is an introduction. So let's say you step on the scale one day and it says you weigh 58.5 pounds. The next day you step on it and it says you weigh 150 pounds. And then on the third day it says that you weigh 185 pounds. There's something very wrong with this scale. The scale is not reliable. So, reliability, the tendency for a test to produce the same results from one assessment to the next. Synonym for reliability is consistency. So, here we have some targets, some dart targets. And two of them are reliable while one is not. The two on the outside are reliable, but one in the middle is not. Now you're aiming for the middle. However, you don't necessarily have to hit the middle in order to be reliable. You just have to hit the same place over and over and over. So the first one, even though they didn't hit the middle of the target, they hit the same place over and over and over, and so that they were reliable. And then the third one, they were able to hit the middle, and they hit it repeatedly, so that was also reliable. But the middle one, you'll notice that they were all over the place. They were not consistent at all. They were not hitting the same place over and over and over. Okay, so reliability. So in studies, we use measures or items to access the construct. And there's this hypothetical true score of the construct, but we never really get the true score when we measure things, because there's always error in what we study. We do our best to reduce error, but we never perfectly measure a construct. But even so, we try to minimize the error. Now, the true score plus the measurement error gives you the results that you get for your study. It gives you the data. Okay, so here's a visual of that. You have the true score and the error leading to the actual score that you got in your study. Okay, so there are different sources of error. So here are two fundamental sources of error: trait error and method error. So trait error are characteristics of the participant that contribute to unreliability. So perhaps an example of trait error would be that the respondent lied while taking the survey or doing the interview. Another example could be that the respondent was sick when they were doing the survey, and so their results were not what they would generally be. So those are examples of trait error, characteristics of the research participant. And then there's method error, and that's error of the test itself, or the researcher, or the testing circumstances. So some examples of that would be if the researcher let's back up. If the participant came into some sort of facility to do the study, the researcher was there, but they brought their kid and their kid was crying the whole time during the survey. That could affect how the person answered in the survey. They would probably be distracted and not concentrating as much. Another example could be that the researcher was grumpy and mean to the participant. And so the participant decided to uh, do the survey but skip all sorts of questions because they were feeling bad about the researcher being grumpy with them. So those are examples of method error. Okay, so here are some sources of trait error: test taking skills, ability to understand instructions, current health, fatigue or energy level, motivation, and luck. Okay, and then researcher slash testing situations as source of error, the method error: unclear instructions or test items, conditions of environment, bias in coding, interaction between researcher and participant. So another example of method error could be that I did this study with Sarah Coyne a few years back on body image, and the research participants would come into the SWICET, or the Kimball they call it now, and they would go into this little office and do the study. But the problem was is that during certain times of the year, the SWICET, or excuse me, the Kimball gets covered in these bugs. And so these bugs were all through this room where the participants were at, and it was distracting to the participants. And so Sarah Coyne eventually instructed us to kill all of the bugs before any of the participants got there that day, so as to reduce the method error. So reducing error: eliminate unclear items, standardize test conditions. So have everybody test under the same conditions rather than some people coming into an office to do the survey, whereas others are at home doing the survey. Moderate degree of difficulty, minimize effects of external events, standardize instructions, and maintain consistent scoring procedures. So here's another visual. Those arrows aren't very good, but yeah, this is pointing, these are pointing, that's pointing. Okay, and so here's another type of classification of error: random and systematic error. So random error is imprecision resulting from natural fluctuations. It's due to chance rather than it being a pattern. And it's not too big of a deal. We could just kind of assume that it will normally distribute. And then there's systematic error. And this is considered the most dangerous type of error in reliability. So it is the imprecision resulting from some underlying systematic pattern in the data or design, also referred to as bias. So some examples of this could be that a researcher is studying people who are blind. And the researcher wants the participants to come to this facility downtown in order to complete the study. The problem is that a lot of blind people have a hard time getting around to the places they need to get. Some are more successful than others, but others end up very isolated. I mean, they can't drive. And so getting downtown would be a huge inconvenience for somebody who is blind. And let's say the researcher decided that they were going to collect data on multiple days, and so the participants had to go there multiple times. I mean, even if they were up for it one time or two times, I think that they would probably get tired and stop wanting to come because of how huge of an inconvenience it was for them to get downtown with their impairment. Another example of systematic error could be with depression scales. So, historically, depression scales have had feminine biases um, with items like I felt sad, I cried a lot, things like that. And so, historically, there have been more reports of women with depression. However, within the last decade or so, they found that men um, experience depression at higher levels than people were thinking they did. The problem was is that they weren't measuring depression the way that men experience it. On average, men are more likely to experience anger with their depression rather than sadness and crying. Crying is considered a negative thing for men, and so they cope with it in different ways. And so the systematic error was in using items that had feminine biases that led people to believe that women, on average, experience more depression than men do, when that may not be the case. So if you look here, trait, error, we split these up. So method could be random, systematic, trait, random, systematic. Although you'd be hard pressed to I cannot think of any trait error that is systematic, but it tends to be more of a method problem. But yeah, with method, it can be random or systematic. So, like an example of a random method error would be that the researcher um, didn't get enough sleep and they didn't explain the study very well to the participant. So that would be an example of random method error, where systematic is more of the pattern that we were talking about, where, like with the depression example, where they were giving participant after participant after participant these questionnaires that had feminine biases. So it was a systemic problem with the method. So here we have observed score equals true score plus error, but then it breaks the error into these different parts. So random trait error, random method error, systemic trait error, systemic method error. Okay.